Hi, I'm Noboru Matsuda. I am an associate professor in computer science at North Carolina State University. Today, I am going to talk about our recent research on learning by teaching a computer agent, SimStudent. So title of my talk today is Learning Algebra Equations by Teaching a Synthetic Peer that Solicits Deep Knowledge Construction Dialogue. So this is about the application of machine learning agent, which is a decent machine learning agent that you can teach. You can interactively teach computer agent. So this agent actually, when you teach, this agent asks questions for you so that you have to think deeply, justify your teaching or reflect your thoughts. We believe this kind of the dialogue, question asking dialogue would facilitate you learn by teaching. So in the current literature, there are a whole bunch of positive evidence or positive observations that when people teach, they learn, which is called learning by teaching, often called tutor learning. It's tutors who learn by tutoring. However, there are challenges when you conduct this kind of research. For example, if you want to study research about learning by teaching in the actual classroom, it would cost you a lot. Some studies actually show students learn by teaching with the expense of tutor. So think about you actually do this learning by teaching study in the classroom, like an algebra classroom. What you do is you split the students into half, right? Half of the students in the class is going to be tutors. The other half of the students in the class is going to be tutors. So tutors teach tutors. However, remember, so those tutors are learning how to, for example, how to solve equations by teaching. However, those tutors may not know exactly how to solve equations. As a consequence, those tutors may teach the tutors incorrectly. Still, interestingly, those tutors actually learn by teaching, but with the price of tutor. I mean, the expense of tutor. Also, as you know, there are so many factors that we can't really control when we do the classroom study. It's not just the intervention on and off, right? For example, like in my case, we wanted to shut down the question asking functionality for the tutor. The tutor agent. Right. So the students learn by teaching with the tutor asking questions. Compare that with learning by teaching without tutor asking questions. Right. So that's the one factor. However, there are so many other factors in the classroom that we can't really control. Also, if it's about the classroom study, without technology, the collecting the fine-grained the data is going to be challenging. So in the past, before computer actually technology become available, the conducting a study in the classroom is really challenging. So the common solutions in the literature is actually using the computer technology, which is called a teachable agent. The teachable agent is a computer agent that you can teach, quote unquote, teach, and then they quote unquote learn how to actually solve problems. So I quoted like this because the not all teachable agents actually do the decent machine learning, the things behind the screen. Some of these teachable agents actually pretend that they are learning, but they are not learning actually. Quote unquote learning, right? But anyway, it's a common practice to use this teachable agent technology, whatever it is, as a synthetic tutor for students to learn by teaching. So our solution is actually SimStudent. SimStudent is a teachable agent. As I said, it's a machine learning agent. So SimStudent has been actually integrated into the online game-like learning environment, which we called A+. Using this A+ with SimStudent teachable agent technology, we have conducted a bunch of the studies in the actual classroom. By doing so, because everything is happening on this online the learning environment, we can actually obtain a precise interaction data, like how students interacted with this computer agent. We can also obviously obtain the outcome data, like pre-test, post-test. If we put them together, we can actually do the decent analysis to understand how and when students learn by teaching. And more importantly, we can understand how and when students do not actually learn by teaching, right? So that's going to be the falsifiable theory or hypothesis that we can validate. So this is a screenshot, sample screenshot of A+ app. So it's an artificial peer learning environment using SimStudent A+. On this A+ environment, you as a student, so pretend you're a middle school student, so you actually teach this the agent here. This Fred is avatar of your SimStudent, computer to T. So you enter an equation on this interface. In this case, you enter 7x plus 6 equals to 10. And then you ask this Fred, the SimStudent, teachable agent, to solve this problem. Your 2T Fred, SimStudent, may or may not do the step by step. So first enter the transformation, in this case, divide 7. And then actually enter the equation, the expression, which is the result of divide 7 on the left-hand side, right-hand side. And then further do the next step. In this case, it's going to be subtracting 6 over 7, blah, blah, blah. Okay. SimStudent, your 2T may not be able to actually do the step. And if that's the case, your 2T agent may ask you what to do next. Now then you actually enter the next step in that case. If instead your 2T knows what to do next, like if your 2T knows divide 7, then the 2T enters divide 7 here, and then the 2T would ask you something like, I did divide 7, am I correct? Okay, and then you say yes or no. Okay, so it's totally interactive the thing. So you initiate the problem solving, you ask your 2T to solve the problem, you provide feedback if the 2T that did something, or you actually demonstrate or you show the solution, a step, if your 2T can't do the step. Okay, as you see here, there's a quiz tab here. And then also example tab, unit overview tab, and introduction video tab, right? So if you click on the example tab, you can actually review the examples of the equations, the solutions of equations, okay? So now you, as a middle school student, your goal is to have your peer, in this case Fred, pass the quiz. So if you click on this quiz tab, it is actually Fred who takes the quiz. So as you see here, quiz has some levels. In this case, one-step equation is first level, two-step equations is second level, and then equations with variables on both sides, it's a third level. Okay, so this is like the like a game, a game show, right? So the Fred needed to actually pass the one level to move to another level. So in this example, Fred actually solved the one-step equation. Now Fred is working on the second level, which is two-step equations. However, Fred made a mistake on this problem, right? So here, this is the problem. Fred did the divided 7 correctly. However, then here he added 6. This is wrong. Okay. Oh, by the way, down here, this is the teacher agent. I'm sorry. This is This is a teacher agent who can help you to teach Fred. Mr. Williams. So Mr. Williams actually graded the quiz that the Fred actually did. Okay. In this case, green means correct. Red means wrong. Because this is wrong, the rest of the steps were not graded. Okay, so now you know your peer, your tutor cannot actually do this equation. So you are now motivated to actually teach this equation, right? So you go back to this Fred tab. So let me back up. So you go back to this interface. I mean to go back here. So you go back to this interface and you teach that equation that Fred actually missed. Okay. So this is the quick overview of the our app A+. Okay. Now, so let me actually go through pretty quickly how SimStudent machine learning agent actually learns. Okay. I don't mean to actually go deeper into the AI technologies here, but just give you a quick actually the overview of how it works. Okay, the SimStudent is actually a computational model of inductive skill learning. So it's an induction, meaning SimStudent learns how to solve problems from examples. Okay. For example, in this case, right, so you entered 3x plus 1 equals to x plus 4, and you actually demonstrated, you as a tutor demonstrated subtract 1 here. Okay, and then you also demonstrated 3x here. Okay, as soon as you demonstrate subtract 1 here, the SimStudent actually do some induction behind the screen, and SimStudent actually creates or composes the rule. This is called the production rule in techie jargon. It shows if such and such condition meets, then do such and such. Okay. So in this case, this rule says if left-hand side is polynomial and right-hand side is polynomial, then subtract the last constant term of left-hand side, which is 1. Okay. Now, there is no free lunch, as you know, right? So for SimStudent to do this induction, or any the students, any human being does an induction, we need to have a prior knowledge. Okay. So, for example, to do this induction, you need to know the concept of left-hand side, right-hand side, polynomial. Right? So these things are a prior knowledge. So these are the concepts that we already gave to SimStudent. Okay. So SimStudent is equipped with this kind of fundamental concepts. Left-hand side, right-hand side, polynomial, subtract, right? Last term, the constant term, right? All these things are already given to SimStudent. Okay, so using these prior a priori given concepts, SimStudent actually can compose this kind of rule. Okay, that best explains the examples you provided. Okay. All right. So how to make SimStudent? Actually, this is the combination of the 3 major AI techniques. One is called version space. Another one is called inductive logic programming. And the third one is called iterative deepening depth first search. Okay. You know, actually, I made SimStudent like the 20 years ago. A couple of decades ago. It's been a couple of decades, which is before like deep learning, right? So there is no fancy deep learning involved here, but still, it's a decent machine learning agent. Okay, so now when we designed the SimStudent, so we made some assumptions for inductive learning. Okay, so this assumption actually was made based on the study from psychology. Okay, human psychology. Okay, so student-induced productions from examples, as I said, right? So you need to see positive examples showing you do this, right? You also need to see the negative examples showing you don't do that. Okay, so remember when you teach SimStudent does some step, and then you said yes, it's correct, or you said no, it's not correct, right? So this no, it's not correct is an example of negative examples, right? So the second assumption is induction is made from individual productions by generalizing and specializing examples. So as I said, right? So let me back up here. So you provide this example, and then from this example, SimStudent composes a production, like a rule. So that's what the second assumption is. Okay. The third assumption is, as I said, right? So you need a prior knowledge. Students must have prior knowledge to actually do the appropriate induction. Okay. So these are the three basic assumptions for inductive logic programming. Okay. So just this is just a repetition of what I said, right? LHS, left-hand side, polynomial, right-hand side, right? Subtract the constant terms. These are an example of prior knowledge. Okay. All right. So the so SimStudent can actually learn how to solve equations in two different ways. One is like through interactive tutored problem solving, like I mentioned on this A+ interface, right? So you provide the problem, you ask students to solve it, and then student does something, you say yes, correct, no, it's wrong, or student got stuck, you demonstrate the step. So that's tutored problem solving. Okay. Instead, you could also simply show SimStudent how to solve problems. Ask SimStudent to silently observe what you did and then compose a whole bunch of productions. Okay. For the current study, which is about the learning by teaching, so we only do the first style, right? So through the tutored problem solving. Okay. However, SimStudent can also possibly learn by simply observing examples. Okay, so now that being said, let me actually share some the experience through field studies. Okay, so in the past couple of decades, we actually used this A+, the SimStudent technology in the actual classroom. So we conducted a bunch of the classroom studies with more than 2,000 middle school students used our technology. Okay, so this photo is an example of students using our technology in their algebra classroom. Okay, so in the past, we actually tested a bunch of hypotheses, and then we learned some lessons. For example, a teachable agent hypothesis. This is the very first hypothesis. It's more like an engineering hypothesis asking, does teachable agent work in the classroom? Okay, so and then we know through the study that teachable agent helps students learn by teaching. Okay, so the teachable agent is actually a trustworthy, robust technology, in particular SimStudent in our case. Okay, teachable agent also helps researchers like us study the effect of tutor learning. Why? Because we can actually conduct a whole bunch of different studies, right? For example, self-explanation hypothesis here, right? So we actually conducted study to see if asking students, like tutors, to justify their behaviors, right? To explain what they did would facilitate tutor learning, right? So to do this, the hypothesis testing, we simply compared students with explanation and student without explanation. right? It's a the random assignment, right? So we randomly split students into two groups. One group of students were asked to explain, and another half of students was not asked to explain. And then we compare their performance, and then data shows when students actually they justify or explain their tutoring behaviors, then students learn more by teaching. Okay. Another test we conducted is about the motivation. So the more engaged the students, when the students are more engaged, then they learn more. So for here, this engagement, we actually conducted the game show study. So we made a little bit of modification for this A+. Now, after each student teach their own SimStudent, their SimStudent actually participated to like a game show, right? So the game show here, we have like a 2 or 3 SimStudents, right? And competing each other by solving kind of challenging equations. The students really wanted to see their teachable agent actually win the competition, right? So that's how we controlled the motivation. Okay, so the meta-tutor hypothesis is more like the recent study. So remember the teachable agent, I'm sorry, the teacher agent, right, the Mr. Williams. So Mr. Williams could help students to teach, okay, in 2 ways. One, Mr. Williams could simply actually tell students how to solve equation, right? Because those students, middle school students, they don't know how to solve equation. But all of a sudden, one day, they were asked to teach this computer agent, right? The usual reaction from the students, you know, is like, a stupid, I don't know how to solve equations. How can I teach my agent, right? So that's a kind of interesting moment. So then we could say, you know what, actually, is teacher agent here, Mr. Williams. You can ask Mr. Williams how to solve equation, and then you can now teach SimStudent how to solve. So that's one condition. Okay, so the Mr. Williams helped students to understand how to solve problems. Okay, that's one condition. Another condition, this condition, Mr. Williams did not actually help, not at all, to understand how to solve equation. But Mr. Williams helped students to understand how to teach. Okay, so like how to teach, for example, Mr. Williams suggested, you know what, actually, why don't you teach this problem next? Okay, or Mr. Williams could say, you know what, actually, you can review examples now, right? If you need. Okay, so we compared 2 different kind of scaffolding here, like a help, right? One is helping about how to solve equations. Another one is helping about how to teach. Surprisingly, we really surprised. Surprisingly, it is actually how to teach that helps. Okay, when Mr. Williams helps students to understand how to solve equation, then the students don't really actually learn by teaching. It's only when Mr. Williams helps students how to teach, the students somehow manage to understand how to solve, and then they really actually learn by teaching. Okay, so these are just an example of the past studies we conducted. Okay, so now most recent study that I spend my rest of the time today is actually about the constructive 2T inquiry hypothesis. Okay, so here we hypothesize, let the 2T ask questions and have students, like tutors, produce the knowledge building responses. Okay, so in the literature, it is known that if the 2T asks questions, right, while teaching, while the tutors teaching, these 2T questions would help. Okay, only when the tutors actually provide the knowledge building responses, which by definition is to refrain the understanding through sense-making process or inferring new knowledge. So that's what this knowledge building is. On the other hand, if the tutors actually only provide knowledge-telling responses, then it won't actually facilitate tutor learning. Knowledge-telling responses, by definition, is paraphrasing or deviating non-information without reflection. Okay. So, here is what we actually implemented. Okay, so the first, this tutor agent, teachable agent, SimStudent asks questions to tutor. For example, why did you say I'm wrong? Or why did you do that? Okay, or when should I actually do addition? Any question. Okay, so if the tutor then responded with knowledge telling, then the teachable agent would follow up to solicit knowledge building response. Okay, so this follow-up actually continues until the tutor actually provides knowledge building response, or maybe we can stop maybe 2 or 3 times of follow-up. Okay, so this is the basic idea of our recent intervention. Okay. So this is an example of the constructive utility inquiry. So the SimStudent asks, why do I need to perform subtask 2? The human tutor says to simplify the equation. Okay, so this here, to simplify the equation, by definition, is not a knowledge building response. So therefore, the SimStudent followed up. I understand that you said what you said, but a little more informative reply would be helpful. Can you explain why subtract 2 is your first guess using the key terms mentioned in the unit overview? Right? So then human student actually responded again. There is a +2 with 3b, and we do the opposite, which is a little better than just saying to simplify the equation. Okay. So now you see the basic idea here, right? So SimStudent follows up, right, when the tutor response is not necessarily knowledge building. Okay. So the question is how we did this kind of the dialogue, right? So this is a little bit of details that I won't actually go deeper, but what we did is we first actually categorized the students the response into 3 types: descriptive, or reparative, or totally junk. Okay, reparative by definition means the student says, "Oops, I'm wrong," right? Or I made a mistake, kind of stuff. Everything else is considered as descriptive. This is some kind of explanations. Okay, so then we see if this descriptive the response includes why component or the what how components. Okay, and then depending on if it's about the why component included, then we see if this response has a key term involved or not. Okay, only when it's descriptive with why component included and the key term used, we consider that as a knowledge building. Okay, so everything else is not knowledge building. Everything else is considered as knowledge telling. Okay, and then depending on the actual the thing the student said, right? So if it's about the descriptive, why informative, however the key term is not included, then the SimStudent follows up, like very informative, but I could not draw a big picture yet, blah, blah, blah. Okay, so in some sense, the current SimStudent, the dialogue is scripted, right? So if it's all sort of this combination here, right? So they are all scripted. Okay, so that's how we do the constructive tutor inquiry now. Okay, so using this technology, we conducted classroom study to answer or maybe explore 2 research questions. Number 1, does constructive tutor inquiry facilitate tutor learning? The second research question is, does constructive tutor inquiry support tutors to develop in developing the skills required for engagement in knowledge building? In other words, research question 2 is asking, do students learn to actually provide knowledge building responses? Okay. So for about the research question number 1, So we actually did the randomized control trial, right? So the half of students actually used A+ with the constructive tutor inquiry. Another half students used the A+ without constructive tutor inquiry. Okay, we for this particular study, we had 33 middle school students from the local schools. Okay, the participants, all 33 students, took the pre-test and post-test before and after using A+ with the intervention. Okay, both the tests are isomorphic. Okay, and then there was no difference on the pre-test, which is the random assignment. Okay. All right. So the result here. So this result shows, right? So the pre-test, post-test. Okay. And then this black, the solid black line shows the students in the constructive tutor inquiry, the condition. A dotted line here is without constructive tutor inquiry. Okay, so as you see here, right? So the students who used A+ with constructive tutor inquiry actually learned a lot, right? So the post-test score is much higher than those who did not use. Okay, starting from the same pre-test point. Okay, so statistically speaking, right? So this difference was significant. Okay, so this graph shows the effect of constructive tutor inquiry. Okay, this may be a little bit of too much detail, but actually the pre-test, post-test contains the two components. One is about the procedural skill test. This test is about if student can solve equations. Okay, and then another component is actually conceptual knowledge test. This test is asking about the conceptual terms in algebra, like term, right, simplification, blah blah blah. Okay, so this graph shows actually the difference between the two groups is stronger on the procedural skill test. Okay, not so much about the conceptual knowledge test. Meaning, the student who used the A+ with the constructive tutor inquiry actually learned more about how to solve equations, but the amount of the conceptual knowledge gained is not that big. So about the research question number 2, the asking if students actually learned to provide knowledge building responses. The answer is interestingly yes, actually. Here. So this graph shows the, it basically shows the probability of students providing the knowledge building response, which is y-axis. X-axis here is the number of the questions, right, the asked. Okay. At the beginning, like the first questions, both conditions, they actually equally likely not providing knowledge building response so much. However, on the 30th problems, or maybe the 20th problem, 20th questions, the SimStudent asked, right? The students in this constructive tutor inquiry condition actually showed much higher the probability of providing the knowledge, the building responses. So this graph shows actually the answer for the research question number 2. The answer is yes. Students actually learned to provide knowledge building responses over time. Okay, so this is the summary of the findings today, right? So research question number 1, yes, the constructive tutor inquiry actually was effective. The students actually showed higher the post-test score than non-constructive tutor inquiry students. And then for the research question number 2, yes, the tutors who used constructive tutor inquiry actually learned to provide the knowledge building responses. Okay. So as a conclusion for my the presentation today, so teachable agent functions as a synthetic peer for students learn by teaching the SimStudent. And the teachable agent technology helps researchers advance the theory of learning by teaching, A+. So we will continue actually exploring the space of learning by teaching using A+ and SimStudent technologies for next decades or so. Thank you so much. I can give you a quick kind of follow-up for the most recent study, right? So we are applying the large language model, like a GPT, to actually drive the dialogue between tutor and tutor. This study, we may have something to share maybe next year, if you're interested. You can always visit our website, www.simstudent.org, to learn more about SimStudent.